Have you ever dropped your keys by accident and watched them fall straight to the ground? That motion, simple, fast, and uninterrupted, is a perfect example of free fall. Free fall refers to the motion of a body under the influence of gravity alone, with no other forces like air resistance acting on it. It's a special case of one-dimensional vertical motion. In this motion, the acceleration is constant and it is equal to the acceleration due to gravity, which we denote by the letter g. This acceleration is always directed towards the center of the Earth, making free fall a uniform and unidirectional motion. A classic real-life example: a stone dropped from the rooftop, assuming there's no air resistance, experiences free fall exactly as defined. Let's now examine a common case when a body is simply dropped from a height, starting with zero initial velocity. In this case, gravity is the only force acting on it, and the acceleration is taken as positive g, directed downward. We use three key equations of motion to analyze such scenarios. First, v equals g multiplied by t, which gives the velocity after time t. Second, h equals 1 by 2 multiplied by g multiplied by t squared, which gives the height or distance fallen in time t. And third, v squared equals to multiplied by g multiplied by h, which gives the final velocity just before hitting the ground. These equations help us calculate how fast the object falls, how far it travels, and how long it takes. But what if we don't just drop the object? What if we throw it downward? When a body is projected downwards with an initial velocity, we still have acceleration due to gravity acting. But now the motion starts with u, a non-zero velocity. The modified equations of motion are v equals u plus g multiplied by t for final velocity, h equals u multiplied by t plus 1 by 2 multiplied by g multiplied by t squared for height traveled, and v squared equals u squared plus 2 multiplied by g multiplied by h, connecting velocity and displacement. These are extensions of the basic kinematic formulas, but adjusted for the fact that the object had an initial push. Imagine a ball being thrown downward from a balcony. It speeds up not only because of gravity, but also because it started with a boost. Now let's reverse the situation. What happens when a body is thrown upward? In this case, the motion is against gravity, so we take the acceleration as negative g. As the object rises, it slows down and eventually reaches a maximum height, where its velocity becomes zero. The equations that govern this motion are v equals u minus g multiplied by t, h equals u multiplied by t minus 1 by 2 multiplied by g multiplied by t squared, and v squared equals u squared minus 2 multiplied by g multiplied by h. Here, the time taken to reach the maximum height is directly proportional to the object's initial velocity. So what exactly happens at the highest point of an upward motion? At that peak, the velocity becomes zero, but interestingly, the acceleration due to gravity, which is g, still acts downward. This moment marks the turning point, when the body stops rising and begins to fall. Although the velocity is momentarily zero, the object is still under the influence of gravity, meaning it is still accelerating, just not changing position for that instant. This condition is essential when calculating total time of flight for upward and downward motion combined. So remember, even when the motion seems to pause, gravity never stops pulling. Let's apply what we've learned with a solved example. Problem: a ball is dropped from a height of 78.4 meters. What is the time taken to reach the ground, and what is the velocity just before it hits? Step 1. We'll use the formula h equals 1 by 2 multiplied by g multiplied by t squared. Substitute the values. 78.4 equals 1 by 2 multiplied by 9.8 multiplied by t squared. That simplifies to t squared equals 16, so t equals 4 seconds. Step 2. Now, use v equals g multiplied by t to find the final velocity. That's 9.8 multiplied by 4, giving us 39.2 meters per second. Final answers: time to reach the ground 4 seconds, velocity before hitting the ground 39.2 meters per second. Let's sum it all up. Free fall is the motion of an object under the sole influence of gravity with no air resistance or external force. It involves a constant acceleration, which we denote by g, always directed downward. The equations of motion help us calculate how high, how fast, and how long the object moves, whether it is falling from rest, thrown downward, or projected upward. At the highest point of upward motion, the object's velocity becomes zero, but gravity keeps acting, guiding the object back down. This simple yet powerful concept of free fall helps us understand more complex topics like projectile motion, orbiting satellites, and even planetary motion.